Okay. Hello,
Okay.
all. I'm Gary Berg-Cross, a co-chair for this Summit 2023 Ontology Summit, and it's March 8th, 2023. And we are going to be doing our second phase of our Ontology Summit, moving into things like ontology design patterns, Wikidata, and things of that nature. First, I should say that the scheduled speaker was called away on a project that he had to attend and has made a video recording. And so we were going to be playing a 35-minute or so video recording later in the session. But first, I'm going to do a few introductory slides overviewing this part of the summit. So with that, let me turn to slide share here, screen share, and show you my first slide. So this has a working schedule for the second part of the summit, starting with on modules and patterns with Cogan Shimazu from Wright State. He'll introduce himself in detail, and it shows that some of the other sessions that we have, basically things are nailed down now. So next week we will have a design pattern discussion, sort of a follow-up to this session with Carl Hammer, who's now at Google, had been at IBM. We have invited some of the original people, such as Valentina Prasuti, to present, but we never heard back from her. So we had Carl stepping up to do that. Following that, we're going to have a session on Wikidata. I'll have a little bit more to say about that probably next week. And you can see the remaining schedule here leading up to a panel, which we still are filling in, but Pascal Hitzler will be one of the main speakers on that. So with that, let me turn to today's session. And I thought I would introduce a little bit of the topic on ontology design patterns and modular ontologies before we go to the video. So this is an example of a widely used pattern, actually, that I was a bit involved with, which is called semantic trajectory, which you see on the left. And you can get an idea about what ontology design patterns are. So we have a range of concepts here. What is a semantic trajectory? How are you to define it? Well, first we defined it in terms of having segments that go from and to places where we do a fix. That is, we take a sensory measure. And that this segment is traversed by some type of conceptually moving object. Most of the time we're thinking of a real physical object, but it may be a conceptual object. So it may be something like a disease that is essentially having a course of action over time, and we're taking measurements on the disease over time. And we have a source for and a sensor type and a location for the fix. You'll notice that most of the boxes have a solid line around them. Yes.
Gary, can you go into presentation mode?
Let's see if I can do that. You want me to go into slide mode here?
Yeah, and make it easier to read.
How does that help a bit?
Thank you. No, not so far.
Okay. All right. I'm going to go on here.
No,
my next slide tries to illustrate the range of things you might see in ODPs, ontology design patterns. On the left, you see a rather complex pattern. Actually, this is an early version dealing with sensors, the sensing things, sensing features of interest. There's actually several patterns probably composed in this. And this particular pattern, the semantic sensor network pattern, for example, has evolved over time and been improved on.
Your slides are changing, Gary. Your slides are not changing.
You don't see two ODP examples on the screen?
No. You are on the first slide.
Okay. I'm talking about the second slide.
No, we don't see it. Oh, second slide, yeah.
You do see it?
Yes.
Okay.
But it would help if you would.
Do you still see the second slide with two ODPs?
Second slide.
There's one diagram.
Okay, well, there's two things on it. On the left side is a complex one. On the right side is a very simple pattern for transitions.
No,
which
no,
events have
we don't see that.
You don't see that.
Gary, I
Let me
think
see if
you
I
are
go out-
sharing
if I
the
go out
original
and-
window of the thing and not what you are seeing. You want to share your screen, not an individual application.
There we go.
There you go.
Yes.
Okay. I was asked to change your mode. Do you see the two patterns now?
Yes.
Okay. So again, to complete this is the complex one on the left, which is dealing with sensors information. And the very simple idea of what is a transition? A transition of an event has a starting time. It's a setting for a thing, and it has a final state. So it transitions from a start to an end. Very, very simple design. Okay. Can you see a new slide now? Why ODPs?
Yes.
Yes.
Okay, fine. Okay. So I wanted to provide a little rationale for some of the things that go into using ODPs. The original idea was that it was difficult to understand and get an overview of very large ontologies as they were growing. And it was also difficult to see the effects of a change or an extension in some concepts, so what would have impact it would have. And also another thing that was said is that it's often very hard to get full agreement on all the commitments on a large ontology. And for these reasons and other reasons, such as interoperability problems and alignment problems, understandability problems, people decided to look at these trade-offs and maybe it would be better to start with something smaller, like some of the patterns that I showed you before. Here's a little bit more on some of this reasoning about what ontology patterns might be like. They reflect, of course, the need to capture the reality that is in data, common to patterns. Often the patterns in data are hard to find, but if we can spend some time looking at that, we can sort of abstract some of those patterns from the data itself, as opposed to a pre-developed top-level ontology. I have a quote here, roughly a quote here from Werner Kuhn, early on in the era when patterns were starting to be used. For solving semantic problems, it may be more productive to agree on minimal requirements imposed on small notions like a pattern notion. So the idea was to use small and well-engineered, coherent, minimally constrained schemas as a start for ontology that later could be combined, as I showed you with the semantic sensor net, where you might be combining several different patterns. You can use very good documentation and design rationalities and best engineering practice for reuse over time. So you can improve things like the semantic sensor network over time. So for all these reasons, people did try out going to modular patterns. And as they did, in roughly about 12 years ago or so, Gangami and Presuti, who I invited to a session but haven't heard back, wrote some documentation on modular operations, and just talked about 5 basic types of operations when reusing them and building them. So the first is, of course, importing them, and you can use al import functionality to do that into whatever you're trying to do. You can also specialize, 2 types of specialization. You can take an existing idea and specialize it conceptually and then go from there. Or you can have a specialization done by creating subclasses and subproperties on existing ODP classes and properties. You can also generalize an ODP and the concepts in them. And one of the most complex things, and you saw a little bit of this in the semantic sensor net, the early version, is composition, where you use multiple ODPs, small pieces, and try to compose them in a meaningful way, fitting them together. And the last one, of course, here is the idea of, well, you may not find an idea in a particular pattern that you want to use, and you might have to develop new patterns for that. And here's an example of just such a thing of an expansion. I showed you that semantic trajectory before. Here we have a portion of that trajectory on the right, but we're sort of extending it and combining it with other things so that a particular project that NSF funded called the GeoLink project used the trajectory for scientific expeditions. And so they specialized the idea of what is traversing the segment to a vessel that might be going on a cruise. And they also added other ideas on that, such as the data is gathered and put it into a repository, things of that nature. So this is just a small example of how patterns get built and get reused. And we'll hear more about that from Cogan, and also next week from Carl. My last slide is just a few sources on that. This is a reference to that semantic trajectory, for example. This is a tutorial sort of on how you combine patterns, make good patterns. This is something on how you document patterns and so forth. So with that, let me stop the share and let me turn the session back over to Ken, who will hopefully start the Cogan's video, which runs about 34 minutes or so, which will leave us with a little bit of time for Q&A, although he's not here this time. He promised to come back next time. When Carl presents, he'll be available for questions and answers. So if we have an important ones we haven't addressed here, he may be able to do it then.
So this is the recording. Hopefully you'll be able to hear the sound, but it's quite redundant. You'll notice that the transcript is on the right, and you'll also see the transcript on the screen as he's speaking.
Hello, everyone. Welcome to my talk. Today, I'm going to be providing a introduction to patterns and modules. And by this, I really mean patterns and modules as they exist outside of the traditional sort of formal ontology perspective. So I'm not looking at the modules and the patterns as they exist inside of, say, for example, Dolce or BFO or any of the other upper fundamental foundational reference ontologies, but instead coming at this from more of the empirical data-driven side of things. We'll go over briefly the methodology and some of the resources. So very briefly, my name's Cogan Shimazu. I'm an assistant professor over at Wright State University in Dayton, Ohio. Some of you have already spoken with me at previous talks, and some of you have just known me for years already, but regardless, I'm happy to be here and talk a little bit about what I'm interested in, and then also the point of the talk. So a little bit more about me is that I'm broadly interested in knowledge engineering, and I mean this from the full perspective or the full spectrum, from just basic knowledge representation from low expressivity, so taxonomies, controlled vocabularies, all the way to full-blown OWL ontologies. But this also encompasses some of the deployment aspects and how are knowledge graphs and these knowledge bases used. And that's a lot of where this pattern-based methodology comes from. Is it's not just about patterns in the knowledge, but also patterns of usage and how you can really simplify how knowledge graphs and the constituent knowledge is really utilized. And then, of course, the next two things are just kind of employing knowledge engineering to do more effective open science and more effective teaching of this material. So kind of looking at knowledge engineering from the perspective of knowledge engineering in order to be a more effective teacher. But I digress by now. So without further ado, let's take a look at the rest of our talk today. There are four main pieces that we're going to dig into, and I'll give briefly a motivation, and then we'll again briefly kind of go over the modular ontology modeling methodology, or MOMO. And then I have a few examples of what patterns look like and kind of some connections to some previous pattern work that we've seen in previous talks here. And then we'll close with some tools and resources. So the first example that I have is called the Nowhere Graph. The Nowhere Graph is a NSF-funded consortium, and I don't mean that in a more formal sense. It's there is no NSF consortium in this case. By this, I just mean that there's a pretty huge team. I think it's over 50 collaborators at this point, and that spans from all of the student researchers to the investigators, the collaborators from NGOs and private industry and government agencies. It's pretty quite expansive and with high coverage. We have a whole bunch of different data sets that come that are contributed by the different collaborators, or we're pulling them from publicly available websites, and we're integrating them all and trying to provide a geospatial backbone so that way the representation of spatial integration is pre-done. We're front loading the cost of doing the spatial integration, and that this came with some pretty tricky and interesting problems with how to adequately express these spatial relations and also ensure that we have provenance from all of the different data sets and all of the different features and do the semantic harmonization. And it turns out that we did wind up using a modular knowledge graph in order to do this. So this is what the schema looked like back in July of 2021 and into 2022, I believe. And each one of these little tiny boxes that you can see here are a module, right? We have an expertise module, we have a hazard module, we have different modules for the different data sets, so climate division, soil types, storm observation, smoke plumes, things that impact the world around us by some physical phenomena, and is also of interest enough that the government at a state or federal level is tracking them and providing data sets about them. And so what we did is we identified a kind of pattern that exists in this observations, and it's drawn from the SOSA SSN, the Sensors, Observations, Sampling, Actuators ontology from the Semantic Sensor Network, and kind of extracting a core piece of that and using that as a sort of template to mint new patterns, which kind of turn into these modules and so on. And this strategy, I think, as both Nick and Chris have said in previous talks, is really effective for rapidly expanding additional coverage for a domain without really having to know the ontology in and out. There's some clear connection points to these strategies. And so what this results in is, as of November of 2022, is this much larger schema, and I don't think this is everything either. And it's also hardly readable because it doesn't fit on the screen. It's kind of an interesting sort of catch-22. It's cool that we've been able to integrate all of these different data sets, but now it doesn't fit on the slide, so we can't really show it off. But anyway, the evolution and maintenance of the graph comes from these patterns and these modules, and being able to rapidly replace a module or add in a new module based on an older module or the same pattern is really instrumental. And we'll kind of go into this in a few slides. Another example that we have is the enslaved hub ontology. So the enslaved hub is a smaller but no less important knowledge graph. It's really about identifying, integrating, and really making visible the stories of the peoples of the historical slave trade. So trying to find how a particular person might have traveled from place to place, largely against their will, and with different names and different personal relationships, and trying to identify what actually is the ground truth, because that's one of the hard things here, is that integrating all of these little tiny data sets from historians across the nation and around the world even, you have different interpretations of the events that occur, or different interpretations of the first source, the first-hand sources. And this resulted also in a modular knowledge graph. Otherwise, we wouldn't be presenting it in this particular presentation. But the point is that having a way of modeling the different types of characteristics of the peoples of the historical slave trade, as well as this sort of integration of the data sets, is really valuable and really makes it easy to apply a pattern-based method towards it. This I will not get into so much with the rest of the presentation, but if you have any questions or you want to see the schema, you can go to enslaved.org, or if you have any questions, my email is at the end of the presentation, and you can go ahead and pass on questions, and I'll either answer them or send them on to the team. So anyway, let's go ahead and dig a little bit more into modular ontology modeling. So one of the things that I didn't really talk about is what is the difference between a knowledge graph and an ontology. And in this case, we don't really mean them to be too differently, except for in this case, an ontology is really just the T box of the ontology, right? And then we consider the knowledge graph to be the A box coupled with the ontology, which acts as a schema for the knowledge graph. Really, it's just changing the different buzzwords around in order to make sure that the work is fundable sometimes, or a little bit more relatable to a broader audience. And in this case, what we mean with pattern-mediated methods for knowledge engineering and including these patterns is really including and using patterns as a first order or first-class citizen within the modeling paradigm. So making sure that the modular ontology is directly represented using annotations. And this is what really drives the ability to expand the ontology or the knowledge graph schema based on the existing patterns within the ontology, or to yank out and say, well, we don't want this one anymore, let's go ahead and replace it with this new one, and then finding all of the pertinent axioms and underlying instances for those classes is quite valuable. And so what we have here on this slide is what we call the modularity, which is the patterns made out of, or sorry, the schemas made out of patterns. And then on the right-hand side, we have the metadata scaffolding. And so this is really the catchy way of saying, well, we're just going to annotate the schema with additional information that indicates what pattern or module particular classes within the ontology belong to. So with this in mind, the metadata scaffolding can really be thought of as this sort of ladder, right? You have a conceptual component, which is an extremely human-centric term, which might be implemented in a number of different ways. For example, space and time are great examples of this, because there's so many different ways of modeling space, right? That we can each say that each ways of those modeling space is kind of like a pattern. And so a spatial extent would be the conceptual component. It would be represented by some set of patterns, and then you choose a pattern and you turn it into something that's more apt for your use case, and we call that a module. And then you have the instances of the modules, which are really just the shapes of the data, the actual triples or the materializations of the data that the module models. We use a language called OPLA, or OPAL, which is the better way of kind of turning the acronym into a human word. Which is just the ODP representation language. So OP, and then the A from pattern, and then L. What I have here on the right is an in-progress draft of the version 2 of Opal. And what we are trying to do here is to include even more information about what is actually going on inside of a pattern. Axioms tend to follow patterns, especially within the MOMO methodology, but there's also different ways of thinking about patterns in terms of their representation. So you can have a perspective, which is really just an extremely simplified view of maybe a more expressive version of a pattern. You have documentation that's associated with it, so the pattern will have a schema diagram. And all of the different ways that you want to represent a pattern, we're trying to codify into this model. There is an additional, there's a base OPLA or Opal, which was published in 2016 from a number of people from the community, and we are kind of generating a new specification currently. So modular ontology modeling now, let's take a look at the actual methodology. It's 9 steps. We want to focus, as I said, largely on the empirical data-driven reality, which means that we're not necessarily always concerned with the philosophical ramifications as we are with what can we model and what data is readily available or important to the use case at hand. So you start with designing the use case with whichever methodology that you want with use case generation, and you can draw from any number of knowledge elicitation frameworks. What we find to be particularly important, and we call out here, is this use of competency questions. I don't think this is particularly new to the ontology modeling community, but it really helps you identify what the key notions are, but also the interactions with the data. And this is really where the empirical or data-driven reality aspect comes in, because if you can't really in natural language ask a question about it, then to what extent is it useful to model beyond that? There's probably some fighting words in that statement, but at this top level sort of this address here, we can sort of gloss over that for now. The interesting parts now are in steps 4, 5, and 6, which are really kind of what differentiate MOMO from other methodologies, and that's really once you have the key notions for your use case, which are extracted from your data, your competency questions, your domain experts, what have you, you want to match those to the conceptual components that patterns model. We have resources that I'll display later on in the presentation of all of the different patterns that we have and can be used to sort of plug and play a schema together. The instantiation of the patterns is what comes next, and that's really replacing the terms and properties of a pattern wholesale, kind of like a template, starting with maybe like Madlib style. You're not subclassing a pattern, you're just using the structure of the pattern over and over again. In step 6, we have the systematic axiomatization, which is once you have your patterns and you look at the schema diagram for your different modules and your different patterns, is you go edge by edge within your schema diagram and you assign the ontological meaning of what that top level intuitive conceptual relationship is. I won't get into that so much within this talk, but what we have here is the modular ontology modeling published in the Semantic Web Journal, and you should be able to kind of get a lot more information on the exact processes within this methodology from there. After that, you plug all of the modules together, quite literally like puzzle pieces. You review the final product, add any more axioms that you think are useful across the entire assembled schema, and then you produce your OWL artifact. So that was really MOMO in a nutshell. So what I have here are a few examples, 3 actually, I think, and then a brief discussion on the template-based instantiation that we utilize for MOMO and how it kind of connects or is quite obviously parallel to the sort of DOS-P strategy employed within the OBO community. So this first pattern that we have here is a pattern for depicting causal relationships between events. This is something that came out of the Nowhere Graph project. Actually, the next 2 patterns are as well. But I kind of want to show you here how you have a pattern and then you also have a module within the pattern, right? This abstract event compared to this event, this concrete notion of an event. For those of you who are familiar with the upper ontology sphere, this would probably be easily modeled as your sort of perdurant, endurant thing, because you have a description and a situation. You have this thing that exists in time and thing that exists out of time. But from a pattern perspective, the exact implementation of this doesn't matter. And that's kind of the point. You can implement this pattern using an upper ontology, or you could call it whatever you want, like event concrete, which is maybe not a great name, but kind of gets the point across. These blue boxes with the dashed lines are what we call the interfaces. I said earlier conceptual components, but you can kind of think of them as interfaces from software engineering because they are an implementation. They are a hook within this pattern that says, right here belongs anything that is a model of what an observation is, or anything here can be fulfilled by something that sort of adheres to the contract of what a spatiotemporal extent is. And we just denote that with the blue box. And so you can replace that blue box with an entire new pattern, or you can kind of just drop it away and have it something very simplistic like a stub, and so on. And so this is how we do that. This is also what allows it to kind of, for people to kind of conceptualize these as puzzle pieces, because you take your spatial temporal extent pattern, you plug it in quite literally like a puzzle piece into the spatial temporal interface within this schema diagram, and then you just build out your patterns and you modify them to your use case, and then you're done, right? That's kind of the strength of what we're trying to do here, is by leveraging these patterns and the fact that all of the ontological analysis has already been done, it's really just the assembly and configuration for your use case that drives the usefulness of this. Okay, I accidentally reordered these. Sorry for flipping through a few slides there. This is another example here of a pattern. We have 2 interfaces this time, but now actually what we have here is this purple box, which is really just a controlled vocabulary. It's just another sort of technicolor idiosyncrasy for our presentation, or our schema diagram presentation. And it's really just saying that the class of organization scheme consists of strictly a set number of individuals. Not particularly exciting, but it's something that we can model and is sometimes extremely convenient to model even at the pattern level. And then doing it explicitly like this, instead of having a subsumption hierarchy somewhere in the background, it means that there's really no change to the ontology when you add in a new instance, for example, here of the organization scheme. In this case, you would replace custom with whatever you want, because custom kind of doesn't belong in the pattern here. Keep moving on. So this final pattern example that we have here, this is a pattern for depicting features of S2 cells or any cell in a hierarchical grid. So let me back up there a little bit. What we have are these cells, and a cell is really just a geometry, a tessellated geometry across the surface of the Earth, or any body really, but in this case, let's just stick with the Earth. And then what you have is these cells are hierarchical. So 4 cells make up the next tessellated geometry, and it just up and up and up. And so S2 is one particular version of this, and that's employed by Google. And it's really just 4 cells make up the next larger cell, and then 4 of those make up there. And there's also a way to do this using hexagons. That's called H3, using it out of Uber. But really what's interesting about this are these red arrows. I mentioned earlier that sometimes it's useful to have these shortcuts within a pattern, a simplified view, right? So when you have a cell and you want to represent it using GeoSparkle or using some sort of geoinformational science standard way, you disconnect the cell as a concept from its geometry, which is the literal that describes the sort of boundary points of the cell. And then the spatial relations actually occur between the geometries, not technically between the cells. However, when you're querying, generally you want to know how the things are spatially related at a human level and not just these arbitrary geometries that exist under the hood. And so having a way to specifically represent these within the schema diagram, useful, but also logically under the hood as a sort of roll chain is also useful. And we use the Opal annotations for the different for the different shortcuts to say, well, this one's optional. You don't have to actually materialize this. It's part of the pattern, but only insofar that you may want to simplify this for other people. So for example, going from cell to the attribute of the particular feature, that simplifies 3 hops with an inverse in there into one simple thing. But you lose a lot of the expressiveness and the ontological richness there. So there are some trade-offs. Finally, as one of our examples, this here on the left is the KWG core ontology and the SOSA SSN kernel that we use. The core is really just the 4 main concepts that we have and some very basic relationships. It's obviously much more built out within the ontology itself, but from a schema diagrammatic and also from this nice compact view, it's useful to only include a couple of these pieces. But it connects into this kernel, and then this kernel, the SOSA SSN kernel, this pattern that we've extracted essentially from that ontology, we just essentially mint, or not mint, we stamp over and over again, 1 per data set, how this connects, right? So the feature of interest remains the same because it's the superclass. But this observation that we have here within the kernel, I accidentally drew the arrow to the wrong thing. It should be to the climate observation and the observation, and then you have the climate observable property and the observable property, right? This is not a particularly exciting implementation or instantiation of the SOSA SSN kernel template, but you can see how after you've kind of changed the names to be more tailored to your particular sub use case, right? Represent a U.S. climate division and its climate observations. There's all of this additional stuff that's now hung off of it, right? We use has simple result instead of has result. The observation has a phenomenon time, and then we go out and we say, okay, at least with this particular diagram, we say that there's hidden or additional complexity, which would be implemented by another pattern or another module elsewhere for a spatial object or temporal entity. All right, so we're going to go ahead and start wrapping up. I have a few things for the tools and resources, and then we'll end with my slide for passing on any questions to me. So the cool one, and this is really a self-insert here, is called Model, the Modular Ontology Design Library, which is a collection of curated patterns. So on the next slide, we have the Ontology Design Patterns portal. This is a huge collection of patterns of varying quality because it contains submissions of patterns which were peer reviewed but were rejected but never removed from the portal, or they have wildly different sorts of constraints on them, ontological commitments that make them very tailored to a specific use case, and you would wonder whether or not they can really be called a pattern, right? So what we did is we took out the patterns that we thought were maximally useful and polished them up. New schema diagrams, made sure that the axioms were consistent, gave in some examples, and kind of organized them by category. And then we described all of them using Opal, right? So model is actually an annotation ontology of all of the different patterns. This, what here on the right, is 13 patterns in version 1. I am working on a second version which contains 32. Some of them are redundant insofar that they are alternative patterns for the same conceptual component or the same interface, right? A couple of different spatial extent patterns, a couple of different event patterns, a couple of different role patterns, and so on. And then model is not just an artifact, it is meant to be a template. Model is a type of ontological collection, which is a collection of patterns. I call mine model because I suppose that's my prerogative, but it could be any, anybody could make a model. Finally, I think I already said this, is that the model encodes many interpattern relationships. So it has what interfaces it provides, and then conversely, what interface it implements, what conceptual component it implements, what are the different specializations and generalizations between the patterns, and what category do they belong to. We already talked about the portal, so I'll move on. What I have here is called Commodity, the Comprehensive Modular Ontology Integrated Development Environment. Quite a mouthful. Commodity is a plugin for Protege. I wrote this as part of my PhD dissertation, so it functions, but it is not like production quality. You know, it's something to use and to leverage, but you might run into a bug here or there. If you do, let me know and I'll try my best to address it or help out. But essentially what this does is it provides a graphical canvas to do modeling with all of the power of OWL. And the coup de grace, so to speak, would be the pattern library, which is the number 2. You can actually drag and drop all of the patterns from model directly onto the graphical canvas, and it will connect them based on those interface points that we talked about. And then you can also customize the sort of semantics that the edges will generate. What do I have here? So here's a quick example of what this looks like. Oh, that was wrong. Let me try that again. So what you can see here is the dragging and the dropping directly onto the thing. It will draw the module around it. When you drag the next one over, it'll connect it on the obvious touch points. And then you can rename stuff and drag and drop and add your own classes and so on. I'm not going to go back because this seems to be fighting me on this. So thank you very much for attending this talk. I'm so sorry that I couldn't be there today. Please forward any questions to me at my email, or go ahead and pass them on to Gary and he could do this. I will also be here next week, right after Carl's talk, which will have a lot of overlap with this sort of design process. And we can talk there, or I can answer any questions that you might have. again, thank you so much and have a great day.
I guess I'll verbally thank Cogan for this, and we'll see him next week. We now have about 12 to 15 minutes for discussion, including questions and answers. Of course, Cogan not being here, there may be limitations on what we're able to say, but maybe we can have some discussion among ourselves here. So with that, I'm looking for hands raised here. And I know there was a small amount of chat in our other online chat. Yes, James, you're muted, but
Here we go. Thanks, Gary. And I appreciate that Cogan was able to present, even though he wasn't able to present. So much appreciated. I did have a bit of a hard time connecting this stuff up to what I do day to day. When I do things that I call design patterns, are usually focused on templates in CSV files or TSV files that get expanded into some set of OWL axioms that define a class. But I guess my question was, so I am aware that there's this larger literature about ontology design patterns that I'm not super familiar with. I guess my general question is how well this talk lines up with kind of the larger literature on these things. I don't know, maybe that's a question for Gary, but other people could chime in. Is there like a single notion of ontology design pattern and Cogan was expressing it, or is it a more diverse kind of field topic, keyword?
Well, it's an interesting question. I'm not sure I can be definitive. I have opinions, of course, and I am not necessarily as up to date on all the literature. If there's somebody out here attending who feels they can certainly speak up. Cogan mentioned setting up sort of a new repository for curated design patterns. And this reflects the fact that people have been building design patterns and posting them, and the idea is for them to have good documentation, to reuse practice, to make connections to other design patterns and maybe upper levels. And a lot of that is missing. You know, when we talk about fairness for ontology, we sometimes find that they lack some of the ingredients of fairness, and so that has been true for ODPs over time. But like the Foundry, there's a sub-community here of people like Pascal and Cogan and the people involved with the nowhere graph, who are trying to pull some of this together and provide more of a community where there are higher standards, existing practices. So I'd say again that maybe it isn't as large a community, and maybe hasn't been as well funded as things in the biomedical field, but this is an attempt to sort of do something of that level quality. And I myself am very much interested in how these two communities can sort of share and cooperate. I mentioned the semantic trajectory as being able to be applied to a course of disease, but I'm not sure anybody has done that. I'm not sure that anybody has looked at what's common about these patterns and how to take a dead simple pattern from OBO and sort of put it in and compose with it along with ODPs from the other communities. That would be an interesting thing to look at, and might be an interesting research article for us to consider. So hopefully I've given people enough time to know maybe more about this and have things to say.
I just wanted to laugh at your bit about being well-funded, because we don't think of ourselves as well-funded and the ontology side of tooling side of things, but we think of ourselves as stealing time and money to build these tools. But but maybe you're right.
Yes, a lot could be said about that. It's a relative question, of course, and continuity is very important where things get started. And the question, so the GeoLink pattern that I sort of identified came out of or built on the semantic trajectory, but they didn't necessarily continue to fund more of that for other types of expeditions and things like that. So some of the concepts can be reused, but necessarily the projects have a 3-year, 5-year type of extent, and one's uncertain about the other side.
That's true. We often have longer time frames than that in OBO, but not always. Thanks.
Okay. I see something in chat, so I'll just read that. In addition to what James asked, what ontology projects do you know, and hopefully it's the community rather than just me, use ontology design patterns for practically during development? Again, that's a much better question to ask of both Cogan and Call. So let's keep that question. I do know that there have been studies which looked at the relative quality of ontologies built by reusing patterns or not. And unfortunately, at the time of the publication I know of, it wasn't great. It wasn't a big help at that time. But again, things have moved along since some of those earlier studies. Ashaya, you have your hand up.
Yeah, so maybe I just ask a clarification questions. In his talk, does he mean that the design pattern we can use no matter what top ontology that we're using? And another one is, so my understanding is that the design pattern, if as logo, so they are not necessarily kind of have the same, using same block, like, but they can still connect to each other. Is that correct understanding?
Yeah, I can maybe address part of that, which is the interoperability question with upper level ontologies. So you notice that some of them had these stubs with the dotted lines, and as he said, and I don't remember his exact words, the idea is you can plug in different things at this particular point. Some of them may be entire patterns, some of them may be a very simple concept, and so forth. So the idea is that the core of the pattern below the dotted line gets reused, and it's in common, so that you can ask some questions across it because there's a common element, a little bit like what Cobb is doing, right? Cobb is providing that core that other people can tap into. But yes, there will be variations depending on whether you tap into Dulce at the top or you tap into Oboe. Or BFO, I should say. So it allows sort of some commonality and some flexibility. It's a compromise there. Maybe somebody else has some other wisdom to add to that, or real wisdom to add to that.
Well, each design pattern will have certain requirements for it to be applicable. And that could make it impossible to use with certain upper ontologies. So but to what extent do these design patterns have those requirements explicitly stated?
So this is very much a bottom-up effort at times, coming from what the data is saying to reflect the reality of the data, as opposed to a more abstract concept above. And so as long as you have COMSTI questions that can answer with the data, can answer real things of interest to a domain, that they feel that's viable. Now, there could be, of course, these different philosophical distinctions at the top level, but the question is whether you have COMSTI questions that sort of tap into that at all. It may not for practical purposes.
Yeah.
Again, this is a question, this is a deeper question that people who are like Cogan and Call can probably provide a better follow-up.
There's a workshop on ontology design and patterns.
Yes, WOP. Regularly,
WOP.
WOP is an annual event.
And I'm sure that some of the people
they're online. The past ones are online, and you can look at the papers. I often do. I was part of the review panel for some of those.
Here who are active in that community who might have some comments.
Yes, we have a few minutes left, so let's hear from people with different experiences on this or different ideas on this. You don't have to be shy because you've heard me talk about it. Yeah, obviously people will know more than that.
Yeah, so hello, I'm Chris.
Hello, Chris.
So I was one of the co-organizers of the last rendition of the workshop on ontology design patterns. So if there's anything in particular you would like me to comment on, I'd be more than happy to.
So we may have questions. What were some of the patterns about from the last, or the issues at that? I didn't attend.
Right, so there were patterns from different domains, one of which was particularly interesting to me, which was about the design of scientific taxonomies. Now, I don't know the details anymore because I haven't reviewed the actual pattern, but each year there are a number of patterns that get published. And one interesting point to notice here is that the patterns that get published are not always following the same structure. So there are different ideas about what a design pattern should consist of, and also how a design pattern is supposed to be reused. And this is also one of the key notions in which I personally think that the notion of a software design pattern differs from the notion of a ontology design pattern. So when we talk about a software design pattern, these patterns are often thought as language agnostic. So they provide us with a solution that could be adopted in different languages. Whereas these ontology design patterns, they are often tailored to a specific knowledge representation language so that it can be reused in that particular formalism. And that is one of the key differences that often get confused between these two different notions.
Thank you. That's a good, although I do know in his, 10 points, that the last step is to produce the OWL artifacts. So up until then, there's some degree of conceptualization, more abstraction, right?
Right. So there have been different proposals for how a design pattern is supposed to be reported. And one of these proposals includes this 10-step or 12-step process where you have to list all the requirements for a particular use case and all the ways in which a pattern can be reused. But that is not standardized in any way. So there are different proposals of how this could be achieved. And this is just one of them. So again, I've tried to actually empirically look at how patterns are reused, and so far it doesn't seem to be the case that there's a standard notion of either the reuse of a design pattern or standard design patterns that are reused consistently throughout ontology. So this is still a very open question.
That's a challenging observation that we want to sort of repeat next week. So I hope you'll be back for that and ask again, because I agree that, this is we're empiricists here. So we want to know what really works, where things are, and so forth, and what can be really reused.
So we have a
you
question.
Looked at MODL model, their curated repository for ontologies, for ODPs? Has anybody else looked at that?
So,
The idea is the importance of building up a
question.
library.
We've got a hand raised.
Oh, okay, I missed it. Maybe it's on the other screen.
Oh, unfortunately,
Disappeared?
they have to go. Hopefully we can continue this next week.
Yeah. Yes, indeed. And so Carl Hammer, who's now at Google, has been very involved in these things continually, and has done a lot of practical development with them, and can speak to that, and can speak to methods used. And since he's went from IBM to Google, there's probably something has been able to do. He may be able to speak at a different degree of abstraction, but he has practical experience. So with that, I think we can adjourn for today, and hopefully see you all again next week, and tell your friends. I hope Chris can make it. Okay.
I'll try to be there.
Thanks, everybody. Bye now.
Bye.